thank you very much for being here. I hope you'll enjoy this talk. We're here to talk about CQRS and event sourcing in a Symfony application. The goal of this talk is not to talk too much about theory, because it's quite like a covered topic. The goal is more to explore how we can actually do in a Symfony application some event sourcing from CQRS and apply some event sourcing techniques. So quickly, I'm Samuel Roze. I'm software engineer for Vika in London. You can find me like on all these like social networks if you want to. I'm happy to answer questions. So basically, this talk is going to be kind of a story of how we can build a Symfony application using CQRS and event sourcing. So the story starts with basically this product. So I'm working right now for almost a year on a project called Continuous Pipe, being a continuous deployment pipeline for Docker containers to Kubernetes clusters. And it was basically a side project at the beginning, and it was something that I've just created the simplest Symfony application with just like normal controllers and stuff. And then at some point, I just realized that I got some attractions and some interest in this application. So I basically started to add features and features and features. And at some point, like every application, maybe, it just basically becomes that. And that is where winner was our amazing monolith. So that monolith that, when we actually add features, at some point, our pace of being able to solve the business problems is actually reduced by the fact that we accumulate the technical debt. And we basically don't know exactly which side of the application to touch. That was one of the main problems. So I basically looked at different options, different kind of like cultures in the software engineering world. And one sentence that actually got me was this one. It's from Eric Evans, from one of his books, which is basically the heart of software is its ability to solve domain-related problems for its users. And that is the key, probably. So actually to solve the domain-related problems for the users. And at some point, I wasn't like focused on the business problems. It was more about how we can actually design the application using beautiful Symfony services, proper design patterns and stuff. But without, at the end, be able to focus and to have just one place that defines the domain of my application. So that sentence comes from this book. Is the domain-driven design. Definitely worth reading. There's also a red version. It's probably a little bit like more simple or use at least a different angle to explain this approach, which is actually trying to just focus on the domain objects, on our business domain. So here we go to like CQRS, which is Command Query Responsibility Segregation. So the idea is extremely simple. We want to be able to separate two different streams. It's the stream of commands and the stream of queries. The commands just say to the system, you are going to do something. And the queries just read from whatever type of persistence, hey, I want the state of this thing. That is the idea. And we can summarize that a bit with this graph. That's the simplest summarize of CQRS by itself, because it's quite a vague concept. And basically, we have two different streams, doing some stuff with our business logic and persisting a data. Most of the time, we want to have like different persistent layer or different storage for the query and the common results. And that works very well with events and commands. And that's where CQRS and event sourcing both are quite popular. So the idea is to have at the heart of our system all the events. So to record everything that had happened in our system. And if we want to like have kind of the same graph, which is a lot more complex, that is this one. So everything comes from the user interface. The beginning is basically a command that is going through a command bus. So whatever from a controller of Symfony, we create a command, we send it to a command bus. That command will be taken by some handlers that are going to talk with our business logic, and then that our domain will be able to raise some events about something that had happened, and we're going to store these events. So we're going to send these events through our event bus, and basically store this event in an event store, and potentially do something else. The key here is that our events are basically the trace of everything that had happened in our system. That means that from the events, we can actually calculate the current state of our system. Obviously, we want to display something for our users. So this read model, or using projectors, we can build some projections that are going to be read by the final user, which is basically through the queries, we can expose some stuff to our users. And potentially some services, which are something when you want to automate some tasks, they are going to listen to this event and potentially do something else. That is roughly to summarize the CQRS and event sourcing approach. That's roughly all for the theory side. So we are the SymfonyCon, so I believe, and I hope that you want to see some code, and that is exactly the approach I really want you to do. So we are going to try to build a simple application, basically based on these techniques, or this principle or architecture. So what do we need? So we are going to build our domain model, which is basically the thing we need to focus on first, creating our domain. Then we need to be able to persist the events and get basically our domain objects from the persistent layer. So we need a repository. Then we're going to focus on how we can actually configure the message buses within the Symfony application. And then we're going to try to use some examples of automatization through services that listen to events, and then try to build a projection. Does that make sense? So our domain. I'm going to use this example of this continuous deployment pipeline. So we're going to take the domain of a deployment, because most of the time we are using the bank example for CQRS and event sourcing. But basically what I want to is to show you that we can use these techniques for any kind of domain. It's just a way we are actually building our application. So a deployment is basically as simple as that. We're going to build one or plus Docker images. We're going to basically display the progress to our user and potentially send a notification to something. That makes sense. So first, we need to define, in terms of code, what is an event? An event is related to an aggregate root. An aggregate being actually one object. One object and potentially everything that will happen around this object. So in this example, the aggregate is the deployment. So an event is related to this aggregate. That means that an event needs to be a class that implements this interface, being that basically we know from which aggregate it belongs to. As simple as that. Then we need a little bit of boilerplate in our domain object. So as I said, everything is related to our domain object, being just a class. So we need just a little bit of boilerplate, which is something that will allow our domain objects to raise some events and to produce some events from something that had happened. And that is basically a trait. I'm not really using them so often, but that's here a good example. We can actually, just using this trait, add the ability to an object to raise some events. So that is the protective method here. And the ability from outside of this object to get the raised events, which is the last method here. And that's all. That's all we need so far. Then we need our business object, our domain object, which is actually the deployment class. What do we need from this domain? Because we directly go to the path of event sourcing, what we want to is to have this domain object being able to raise events, and we don't want to be able to construct the object just using the normal constructor. That's why this one is private. The only way we want to allow this domain object to be constructed is through events. So that's basically why we have the public function from events that takes as an argument a list of deployment events. For each event, when we create the object, we need to create some state in our aggregate. And basically, how we can actually do that, we're going to apply this event on our aggregate. Apply is just a PHP function. And that function will be responsible for creating the state in our object. So that's the example. Let's say we have a deployment created event. Then basically, when we apply this event, what we can do is to start to build the state of our aggregate. So basically, in this example, just put the UID of the current deployment in that field. And we're going to start to build the state, and potentially we will be able to have some business logic around the state that is in the object. To summarize, just basically have this graph, which is just represent the fact that our domain object, our deployment object, can just be created from events. For each event, well, each event will be applied on our domain object. That apply method is going to write in the state of our object. Then later on, we're going to have some commands in the CQRS point of view, which is just a public method on our object that will do something. So we're going to ask to our aggregate to do something. And basically, this example of the do something method will read from the state to first of all check if it's possible to do that. And then, if it's possible, then raise some events that say, yeah, I've done that. And basically, by raising these events, we just allow something to take these raised events, using the raised events method that come from the raised event capability trait, to actually send these events back to the event bus and do some persistence and stuff. That is the base idea of the simple beginning of a domain object that is constructed for events. I hope that makes sense. It's quite different from an entity. That's how we can actually construct this object from events. So I kind of like testing. I kind of like TDD, being test-driven development. So we can start a state by testing something. If for those who don't know, that's basically a Gherkin scenario that's just basically a representation of a test using the natural language. So it's defined using given steps, when steps, and then steps. So given, we have a different context. When I do something, then something should have happened. As simple as that. And this scenario is quite simple. But it's just to highlight that maybe it's not the best one. Because when I create a deployment, then a deployment should be created, it's kind of simple, and kind of too simple. It's just to highlight that actually, already here, we potentially have some business logic. We potentially need to do something rather than just creating the deployment. So here's an example. From this extremely simple use case, we can already think about two different scenarios. The first one being, well, if I want to create a deployment with 0 images to build, that makes no sense. It's no sense at all. So we're going to say the deployment is invalid. Second example, but actually I create a deployment using 1 image. That's fine. So we can actually, the deployment should be created. Who knows Biat in here? It's quite a lot, man. Nice. So for those who don't know, that is basically every step in our scenario, in our Gherkin language, is basically matched to a PHP function that is doing some stuff in a context file. Context file being just a PHP class. So to do something behind when I create a deployment with X image, here is basically the code that we can do. So we can say that we don't have any deployment so far. So we can say that we're going to put the deployment variable in our context so we can access that in the next scenarios, in the next steps, sorry. And we're going to say, okay, so if I want to create a deployment, why not creating just a public static function of the deployment object? And use that. We're going to create it with a generated UID plus a number of images as basically an array of strings. And if there's an exception, we just put it in our context file so we can find it later. And then to verify that actually the deployment is not valid, well, we've put our exception in our property. So the next step is basically just checking the exception and its type and say if it's not an invalid argument exception type, then something went wrong. So we actually throw an exception in our tests. And it's basically almost the same thing for when the deployment should have been created. Well, we just take the deployment object and we check the raised events, and from them we just filter the events that are basically the deployment created event. If there's 0 of them, that means that we didn't create the event, the deployment. Does that make sense? So TDD, we write the test first. So then we need to do something probably now. Maybe create the create public static method, and then create the deployment created event. So let's start from creating from the beginning and the create method. What is that about? So as you can see in the first line, we already have our business logic. Because we create from a UID and a set of images, we just verify that if there's 0 image, we throw an invalid argument exception. That makes no sense for our business to deploy something without any image. And basically, we then create the deployment created event inside this method. And what we can do is to then create the deployment from the events. The list of events being just one event, the deployment created. And then, what we need to do in this case is just raise the events. So when we raise the event that way, we can actually extract the event from the domain object and send it to our event bus and event store. And that's all. And the deployment created event is quite simple. This is just a PHP class that is matching the contract of being a deployment event, and basically having two parameters, 2 arguments in the constructor and 2 getters. That's all we need. That's our event object. And then if we run the test at some point, it's actually green. So we already have domain testing, as easy as that. And we actually already have some business rules, but we need 1 image at least in our deployments. Next step. Second example regarding this domain testing and actually our domain object. What about starting a deployment? Well, here to like two cases, we can probably find many other ones, but two simple ones. Well, I can start a deployment if it was created, and I cannot start a deployment if it already was started before. That makes sense. So, same again, TDD, we're going to write basically the PHP code behind these different steps. I'm going to just focus on 2 of them, because the rest are exactly the same one than what I showed just before. The first interesting one is when a given deployment was created and started. So we just express the fact that the deployment was created and was started. An event is describing something that has happened. So basically what we can simply do is to create our deployment object from these 2 events. Deployment created and deployment started. And that's all. That's all we need to do. Same thing with cache the exception, so we can actually check the errors if there is an exception from. And the test, which is when I start a deployment, well, I don't want to do fancy things, or I just want to start a deployment, so what about just calling the start method on our deployment object? And that's all. That's all we need. And the 2 then steps are exactly the same one than the one before, so we can reuse them. So, starting a deployment. I hope you can see it properly. The first, so what we added here is a private property being started, which is by default false. So by default, the deployment wasn't started. Then we create a start function, which is our command, basically, that says, hey, if this is already started, then there's something wrong. I cannot do anything, so we throw an exception. And then if it is actually if it's not started, then we raise an event that is deployment started. The deployment, yeah, it actually started. And this is our apply method at the end that we just used to populate the UID before. We're going to do the exact same stuff for the deployment started. When we encounter the deployment started event, then we're going to just put this started equals true, because we are building the state of our domain object. And that's all. And we already have 4 scenarios of test, 10 steps, and we actually test the domain model. And we're done. So we already have the core of our application is done. The rest is basically some plumbing and stuff, almost. So next step is, we have these events, but actually, well, they are not like, we don't do anything with them so far. So next step being the repositories and the persistence. So first, because the events are the only source of truth in our system, we need to persist these events. And we're going to use an event store. An event store being just something that matches this contract. This contract being, hey, I can find some events using a deployment UID, my aggregate route, and I can add some events. An important thing to note here is that the event store happen only. So we don't update stuff. We just happen some events, and using the events, we update the state on the fly of our domain object. I won't talk about the implementation details, to be honest, because you can use an in-memory store, you can use a doctrine, you can use whatever you want, but actually you just store them. The simplest thing being, I'm going to have a MySQL table at the aggregate ID, being the deployment UID, the event class, and the serialized event. And you can serialize them and deserialize them. As simple as that. Next bit, being our deployment repository. So because we want to use our domain object, we want to be able to get our object. So we need a repository to find our object. So this one is basically as simple as that. We just want to be able to have our deployment object from its UID. Basically, that's probably the only implementation you're going to need. Well, because we can construct our objects from a set of events, and we've previously used and implemented our event store, well, we can just simply create our deployment object from the events that are coming from the event store. And that's all. That's all we need to do. Nothing else. No doctrine mapping configuration, anything. That's all. So now the plumbing. So basically, we are in Symfony, so we need to plumb stuff. And we also need some buses. So we can create the wheel again, create our own buses and stuff, but maybe we can reuse something. So what I'm using, and what I really like, is SimpleBus, being a library written by Matthias Novak, and that have a Symfony bundle, so we can easily integrate with Symfony, with these 4 lines of YAML. And basically, it creates an event bus and a command bus in our Symfony application accessible from the container. So we just have an event bus and command bus service. And there's a lot of extension points that I'm going to use later, but then there's in Symfony, the Symfony integration, you just create listeners and handlers extremely easily with just a service tag. So if we step back a little bit in our domain, we already know in Symfony, so what we need is an HTTP interface. So let's create one. The simplest one being, well, we're going to just create a controller, Symfony controller, that makes sense for everybody, I believe. And then that controller being a controller as a service, so we have a real view of actually what are the dependencies of our controller. Our create action is just creating our deployment object the same way we did in the tests. Just taking the Docker images from the requests. You probably need some validation a bit more than that, but that's the idea. And then from this deployment, we're going to take all the raised events from our aggregate and dispatch them to the event bus. And that's all we need. Another way, which I kind of prefer, which is actually using commands. We have this command bus, so why not? So if we rewrite it a little bit, what we're going to have is, instead of having the event bus directly as a dependency, we're going to have the command bus. The command bus, and we just put a command in our command bus being, hey, create deployment command with the UID, generated UID of our deployment, plus the same data coming from the request. If we have a command, we probably need some command handler. And if we create the command handler, that being just a class. In the SimpleBus basically convention, a command handler is basically just a PHP class with an handle method that takes the command as an argument. And then we do exactly what we've done before in our controller. But that's all. We just create the deployment object and dispatch the raised events. A bit of plumbing. So we like the XML. So first, create our service. That's just a create the controller that is a simple service. and then create our command handler that is going to execute some stuff when we push a command in our command bus. And here we go. The only thing is a normal service. The only difference is we have a tag, command handler, that just say, hey, I handled this create deployment command. And that's all. So what do we have right now? It's quite like not so many lines. Well, we do have an HTTP API that basically creates a command, sends a command to the command bus. We have a command handler that is handling the command, creating our deployment object. Our domain object, our deployment object raise some events, and these events are sent to the event bus. Right now, we have already something that is kind of working. The trick being, well, as far as I know, we don't yet store the events that are sent. So we have an option, which is actually, well, maybe after calling the event bus handle, we can actually just store them using the event store. But it's kind of tricky because every time we send an event in the event bus, then we would need to actually put this line which is storing the event. What we can do with SimpleBus and its message buses is to create a middleware. And that's what a middleware is. It is just a class that implements this contract, which is message bus middleware. So basically, every message that we dispatch on the event bus will pass through this class. And what we do is that if this message is a deployment event, well, we just store the event in the event store that we've implemented just before. And then we actually pass the message to the next middleware that is at the end, like potentially send the message to some listeners. That's all. And a bit of XML. Yeah, our class that one dependency, the event store, and we just tag it to be the event bus middleware. And that's all we need to do. So now every time we actually display, publish, or dispatch an event in our event bus, it is stored in whatever the storage method you prefer. So now they are stored. So what we can do is to, from the deployment repository, get our deployment object as it was before. So we can already have in different requests, we can recreate our deployment object from this event. That is basically event sourcing. And that's all. So let's try to go a little bit more with more advanced, or actually more examples. So if we want to basically, let's say, automatically start our deployments, so we're going to create a service. We can use other names in the CQRS area, but the service is fine. So what it is basically just a listener, an event listener that is going to listen to our event bus and do something. So if we want to start a deployment after it was created, we have some conditions before. Typically, well, is there already a running deployment, like some concurrency limits, and this kind of example. All the business-related problems. We should probably delegate that to our deployment object directly. And then actually, this listener is just saying, hey, let's start a deployment. Okay. And I send a start deployment command to the command bus. And if we have a command, we have a command handler that is as the previous one, just saying, well, actually, okay, I'm going to get the deployment from my repository and start it. And if you remember our test, our domain, we just use the start method. And that's all. And then we did do the same thing. We get the raised events, and we send them to the event bus. And we still need some plumbing. And the plumbing being the first one is the listener. So in the SimpleBus kind of like terminology is an event subscriber that subscribes to this given event, the deployment created. And we need, because this listener is sending some commands, we just register the command handler just this way. And that's all. So what happened now? So basically, at the end of what we had before, we were dispatching a deployment created event. And then this listener now is listening to that and say, okay, right, so I want to send a start deployment command. So it's going to the command bus, and then actually the command handler is run. And what is this command handler doing? Getting our deployment from our repository and calling the start method. and getting the raised events and storing them. And that's all. So I don't want to go too much on these details, but you'll probably go further if you actually want to apply that on your application. So, for example, here I have a Docker build. I'm building from a second microservice that is basically just another microservice that is responsible of building, and this stuff is just sending me a webhook back to this service. So what I will do is have another method, which is kind of like the start method. But I say, hey, I finished the build with the build object. The build can be failed or can be successful. If the build is failed, then basically I'm going to raise a deployment failed error, which is basically a deployment failed event. And then I'm going to return. We can even put that on the same line. And if not, when we are going to still potentially construct our state, we can actually say, well, so this, I'm going to add this build image. And then, if at some point we have the same amount of build image, the amount of the images we wanted to build, well, the deployment is successful. And we're done. Next bit, which is basically the dependencies. Most of the time we want to do something like start or do some stuff, we'd have some dependencies. One way that we usually do, and at least I was usually doing, was to, dependency, we need to inject that stuff in the constructor. Well, now our constructor being private, and we can construct the object only from either create or from events method, well, we need to do something else. Because we cannot do that. If we can potentially, but we're going to have this long of argument in the two static constructors, and that makes no sense. So what we can do is to the inversion of the dependencies. We can just do that. So basically what you're going to do, even when the start was kind of simple, we probably need to call some APIs and stuff. But as the same example, if I want to notify somebody about the deployment, well, my command handler can have this notifier dependency, and then call the notifier with the notifier as an argument of my notify method. And then it can raise events, etc., if we need to. Last but not least, the projections. The idea is, because you construct your aggregate from the events, at some point it can be a bit too much. And it's probably too much to each time get all the events, construct the states, and show something to the customer. So that is basically this other side of the queries. And that's why we're going to use projections. Projection is just like dumping some stuff to storage. It's usually a completely different one, probably a document storage, that says, hey, what is the status of my deployment, for example? And projector is nothing as actually just a listener. So we have some events, and we can actually just listen for these events and say, well, I'm going to get the deployment object. The deployment object, by getting this thing from the repository, is loading potentially all the different events and actually building its state inside. So we can actually say, for example, we're going to compute a percentage of evolution in our build, which is the number of built images divided by the number of images that we want to build. And then we're going to just store this stuff, this raw PHP array, to our storage. And this is the extremely efficient way to, from the query side, just take our storage here, and then it's going to be extremely simple, extremely fast. And that's how you can actually build different projections. And you obviously going to have many different projections potentially for one given aggregate. So deployment can be, what is the status right now of my deployment? And I want to create a list of the last, 50 deployments, for example, this kind of stuff. A last bit about the testing. So one thing that I showed you at the beginning was testing. It's probably the domain testing, especially testing on these objects. It's extremely simple with this kind of architecture. And it's probably the domain testing is actually maybe one of the missing bits in most of the application and the source of our extremely long-running test suites. And now that you have that, what you can also do is to try just test the domain object, and then also have different layers of testing, which is now you can also try to send a command to the command bus, and check in your event store if that event is actually here. Even if you like step back again more, you can actually use your API and check that your projection is actually properly built. But you don't have to test the entire application stack for every different scenario. You can actually have all the tests for the domain. They are going to be extremely fast. And then you can have your smoke test or integration tests that are using the command bus or your API. So just to wrap up, so what did we achieve so far? So basically what we have is like incoming HTTP requests. This controller is going to create a command and send it to the command bus. The handler is going to talk to our domain and say, hey, just do something. The domain is going to raise some events. The events are going to be dispatched in the event bus and stored. And then we're going to actually build some projection to allow like a extremely fast querying of our kind of like domain projection of something we need to present to the customer. And we have just one place where we can actually control the state of our deployment and all the different like, conditions of our deployment. Obviously that file can grow, but you will soon probably create like sub-aggregates. So basically the aggregate root is this deployment stuff, but it can delegate to some other objects. And that's how you can actually see that really like decoupled sub-aggregates, basically, or aggregates. So right now you have all these events with Quay. There is like a lot of advantages, and you probably know most of them, but you have an audit trail for free, because you actually store all the events, and you know exactly what have happened. And you can basically potentially do some play, so start, pause, restart stuff, because you just stop the events to being like stored somewhere. You have like many different possibilities just by using this kind of architecture. So I believe that, I hope at least, that this talk like try to help you a little bit how we can do that in the Symfony application, and like at least incited you to try out this kind of approach, and you'll see all the benefits. So thank you very much. So do you have any question? I don't even know if I have time for questions, so let's take some.